Hi everyone, welcome to a new video of JSET classes. In today's video, we are going to do the previous year questions of NEET. And today's section, we are going to do the physics chapters. That is the chapter 1, the units and measurements. And the speciality about this video is we are going to do the previous year question papers in not only chapter wise but also in a unit wise, in a topic wise manner. Okay, so if you haven't subscribed to my channel, please subscribe and please also remember to press the bell icon. Okay, so let us start the video. So first of all, we can take the first question. The unit of thermal conductivity is. So we are asked to find the unit of thermal conductivity. And in this video, what I'm going to do is I'm not only going to say the answers, but also I also try to explain the concepts to you so that you can understand the things in a better way. So if you are familiar with the concept, you can skip that portion and go to the solution part directly. Okay, so the first question is the unit of thermal conductivity is. So certain options are given. This question is asked in 2019. So let us first discuss what is thermal conductivity. So thermal conductivity of a material, it is the property of a material. So thermal conductivity shows the ability of the material to conduct heat. Also, the thermal conductivity is denoted by using the English letter K or using lambda or using the Greek letter kappa. If a material is having low thermal conductivity, it means that it is having a low rate of heat transfer. And we use these types of materials to make thermal insulators. And usually metals have high thermal conductivity, which means that metals have high rate of thermal conductivity, which means that metals transfer heat at a high rate. So let's derive the equation for thermal conductivity. Consider two environments T2 and T1, and a material and a slab of material is placed between these two environments. Okay, so this T2 is having a particular temperature and T1 is also having a particular temperature. But T2 is greater than T1. It means that the T2 is more hot than T1. When we place a metal slab in between these two environments, we will see that the heat transfer from T2 to T1. Okay, that is familiar for you. So the amount of heat transfer is denoted by the letter Q. Okay, so the amount of heat transfer Q, let Q be the amount of heat transferred in T time. Okay, so the amount of heat transferred in 1 second, that is in 1 second, the amount of heat transferred is, in 1 second, the amount of heat transferred can be written as Q by T. Or in other words, what is Q by T? Q by T is the rate of heat transfer. Q by T is the rate of heat transfer. That is the amount of heat that is transferred in 1 second. So what are the factors that depends upon this Q by T, or how much the amount of heat in transferred in a particular time? From analyzing the figure, you will understand that the Q by T will be directly proportional to the temperature differences. That is T2 minus T1, which means that if there is more temperature difference, the rate of heat transfer will be more. And if there is less temperature difference, it will take more time for the heat transfer. Or in other words, the rate of heat transfer will be more if the temperature difference is more. And another factor that affects the rate of heat transfer is the area, is the cross-sectional area of this material that is placed between these two temperatures. This cross-sectional area is A. And if we have a material with more cross-sectional area, the rate of heat transfer will be more. For example, if you touch an ice cube, if you touch an ice cube with your finger, then you will feel less cold. And if you touch the ice cube with your hand, you will feel more cold. That is why is that? Because the rate of heat transfer will be more when the area is increased. So the q by t is also directly proportional to area. And we have the thickness of the slab is denoted with the letter d. From the figure itself, you can understand that if the thickness of the slab is more, if the slab is having more thickness, then it will take more time for the transfer of heat from one slab to another slab. So as the thickness increases, the rate of heat transfer will decrease. So therefore, thickness is inversely proportional to the rate of heat transfer. Okay, you will understand. I think you have understood up to this. So therefore, we get the rate of heat transfer Q by T is directly proportional to the area, and also is directly proportional to the temperature difference, and is inversely proportional to the thickness of the slab. And to remove this constant of proportionality, we can use a term called the thermal conductivity constant, which is denoted by K is and we can write K into A into T2 minus T1 the whole divided by D. This K is actually the property of the material. If we use a metal for the conduction of heat, it will transfer the heat more quickly. That means the metal is having a more thermal conductivity. And if you use thermal insulators like plastic or rubber or paper in between these two plates, it will conduct heat slowly. That it means the thermal conductivity of plastic, paper, etc. is very low. So this thermal conductivity is this K. So this K depends upon Q, the amount of heat transferred, the time, area, temperature difference, and D. So writing an equation for Q, we get K is equal to Q into D divided by T, time into area into temperature difference, that is T2 minus T1. Okay, therefore the unit of K, the unit of K is equal to what? The unit of temperature, that is the heat energy, is Joule, and the distance, that is the thickness, that is in meter, and time t is in second, and the area is in meter square, and the temperature difference, that is in Kelvin. Okay, note that the capital K is used to denote the Kelvin. And here we have meter square and meter square cancels, and the remaining is joule per second meter Kelvin. But we know that this joule per second can be written as watt. Watt is the unit of power. So therefore the unit of K is unit of thermal conductivity K can be written as joule per second, that is watt, then meter inverse, also Kelvin inverse. The unit of K is watt, meter inverse, Kelvin inverse. So let us check the options. So we have here watt, meter inverse, Kelvin inverse. So this is the answer. So let us move on to the next question. The second question, it is asked, the density of a material in CGS system is 4 gram per centimeter cube. In a system of units in which the unit of length is 10 centimeter, so the unit of length in the new system of unit is 10 centimeter, the unit of mass is 100 gram, and we have to find the value of density of the material in the new system of units. Okay, so we know that the density, which is equal to mass by volume, or we can write it as mass divided by volume is length cube. So whatever be the system of unit, we can express density as the unit of mass divided by unit of length whole cube. Okay, so in CG system, when it is given that in CGS system the density is equal to 4 gram by centimeter the whole cube. Okay, the unit of density is 4 gram by centimeter cube. So we have given a new system of unit. In new unit, in terms of new unit of mass, that is equal to new unit of mass is 100 gram, and we have given that the new unit of length, that is equal to the new unit of length is 10 centimeter. Okay, so I will write it in the new page. Okay, so new unit of length is, we have new unit of length is given as 100 centimeter, and new unit of mass is given as 100 grams. Sorry, it's 10 centimeter. 10 centimeter and 100 gram. Okay, so we know that any quantity can be expressed in terms of this equation, that is Q is equal to N into U. If there are different system of units, we can write it as N1 U1 is equal to N2 U2. For example, if we have 1 kilogram of rice, we can say it is equivalent to 1000 gram of rice. Here we have N1, that is one numerical value, and the unit, we have the numerical value in another system of unit and its corresponding unit. Similarly, also we can write the density as, here we have given 4 as the numerical value. And in CGS system, we have gram as the unit of mass and centimeter cube, that is centimeter the whole raised to minus 3 is equal to, we don't know the value of N2 in the new system of units. So let us take it as N2. The new unit of mass is 100 gram. Therefore, we can write 100 gram into the new unit of length is 10 centimeter. That is 10 centimeter the whole raised to minus 3. What we have to find is, we have to find this value of N2. In order to find the value of N2, we have to bring these two terms to the side of the equation. So we can write 4 into, we can write it as 1 gram divided by, bringing 100 gram to this side, we get divided by 100 gram into, and also bring this 10 centimeter here to the, that is 1 centimeter divided by 10 centimeter the whole raised to minus 3. Okay, so from here gram and gram cancels, centimeter and centimeter cancels. So this part, that is 1 divided by 10 the whole raised to minus 3, that is 1 divided by 10 the whole raised to minus 3. That can be written as what? 1 divided by 10 raised to minus 3. So bringing it up, we can change the sign, that is 10 raised to 3. So for the value of N2 is equal to 4 into 1 by 100 into, that is 10 raised to 3 is 1000. Cancelling two zeros from here and from here, we get the value of N2 is equal to 40. So therefore in new unit or new units, that is where the unit of length is 10 centimeter and unit of mass is 100 gram, the numerical value of density will be 40. So let's check the answer whether 40 is given in options or not. Yes, 40 is given here. So the answer is 40. So let's check the next question. The unit of permittivity of free space epsilon 0 is. This question asked in 2004, and we have Coulomb square by Newton meter square, Coulomb by Newton meter square per Coulomb square by Newton meter square. So let us understand what permittivity is. The permittivity of free space epsilon 0, it actually represents the capability of the vacuum to permit the electric fields. That is what meant by the constant permittivity, or it can be represented as epsilon zero. You know that you will study the Coulomb's law in later chapter, or if you are 12 students, you know that what Coulomb's law is. If you have two charges, that is Q1 here and another charge Q2 here, and if it is placed at a distance r, then the magnitude of force between these two charges when these charges are placed in vacuum can be given as 1 by 4 pi epsilon 0 into Q1 Q2 divided by r square. So this 1 by 4 pi epsilon 0 is a constant that is used here. So you know that the 4 pi is a dimensionless constant, that is they have no units, and you have to find the value, the unit of epsilon 0. So the unit of epsilon 0 can be written as epsilon 0 is equal to bringing epsilon 0 up and f downwards. We can write it as Q1 Q2 whole divided by 4 pi into f into r square. Okay, so therefore the unit of epsilon 0 is Q and Q2 are charges, and the unit of charge is coulomb. So coulomb into coulomb, that is coulomb into coulomb. It is also coulomb. Coulomb into coulomb, we get coulomb square, the whole divided by the unit of force is Newton, and the unit of distance is in meter, so we get meter square. So we get Newton meter square. Okay, so let's check the answer. The unit of epsilon 0 is coulomb square by Newton meter square. Yes, here we have coulomb square by yes, Newton meter square. D. Also remember the value of epsilon 0. It is 8.854 into 10 raised to minus 12 coulomb square per Newton meter square. So let's check the next question. The unit of Stephen Boltzmann's constant is. This question is asked in 2012 IPMT exam. So let us check what is Stephen Boltzmann's constant. Joseph Stephen and Ludwig Boltzmann were two scientists. What they did is they both derived a law for the radiation that is emitted from a black body. And this law is called the Stevens-Boltzmann's law of black body radiation. Okay, so let's check what a black body is. Actually, black body is an ideal body, or that is a theoretical object. And what the property of black body is, it can absorb any amount of radiation that is incident on it. Usually for normal objects, what we have is they can absorb a certain amount of radiation falling out it, and they will reflect the remaining part to outer space. But for a black body, it will absorb all the radiations that is falling out it. Okay, they will whatever be the incident angle, whatever be the frequency of incident radiation, they will absorb all the radiations that is falling. Not only they absorb, but also they can emit the old radiations that's in the corresponding frequency. So black body, for in brief, we can say that black body is also a perfect absorber of radiation, and it is also a perfect emitter of radiation. So what this Stephens-Boltzmann's law states is that the Stephens-Boltzmann's law describes the amount of energy that is radiated from a black body. Okay, so it will depends upon, they found that Stephen and Boltzmann found that the amount of energy that is radiated from a black body depends upon its temperature. So the Stevens-Boltzmann law says that the radiated energy by a black body per unit area in unit time, therefore unit area and unit time is proportional to the fourth power of the absolute temperature. Okay, the amount of energy that is emitted from a black body depends upon, okay, its fourth power of temperature. The energy is radiated. We measure the energy in a unit area in a unit time. Okay, that's proportional to the fourth power of temperature. That is, we can write it as E as directly proportional to T raised to 4. So we have E is directly proportional to T raised to 4. Remember, this E is energy per unit area per unit time. In unit area, in unit time, how much energy is emitted, and this T is temperature. Okay, this is temperature. Therefore, to remove this constant of proportionality, they introduced a constant which is known as the Stephens-Boltzmann's constant. This letter is the Greek letter sigma, and this sigma represents the Stephens-Boltzmann constant. Or we can write sigma is equal to E divided by T raised to 4. Okay, and from we get the E is, this is energy per unit area per unit time. So we can write the n unit of sigma as, you know, the unit of temperature is Kelvin, right? So unit of sigma is equal to energy. Unit of energy is joule, and the unit of area is meter square. Unit of time is second, and we have Kelvin. Temperature, unit of temperature is Kelvin, and it is raised to 4. Therefore, we have Kelvin raised to 4. And you already know that the joule per second, that is nothing but watt. Therefore, the unit of sigma or Stephens-Boltzmann's constant is watt meter raised to minus 2 Kelvin raised to minus 4. Okay, so this is the unit of Stephens-Boltzmann's constant. So let's check the answer. So we have watt per, okay, watt per, that means this watt, we got watt meter raised to minus 2 Kelvin raised to minus 4. This can be equivalent to what? 1 watt per meter square Kelvin raised to 4. So this is the answer. Also, do remember the value of this Stephens-Boltzmann constant. Actually, this you can remember it. Maybe in last year, in 2020 exam also, sorry, in this year exam also, they have given all the values of constants. So I think you need not have to remember, but remembering it will be good. So the value of sigma is 5.6704 into 10 raised to minus 8 watt per meter square Kelvin raised to minus 4. So let us move on to the next question. In a particular system, the unit of length, mass, time are chosen to be 10 centimeter, 10 gram, and 0.1 second. The unit of force in this system will be equivalent to. So we have to, and you have to read this sentence carefully. The unit of this force in this system will be equivalent to. Okay, you have to find the units of force that is equivalent to new unit of force. Okay, let's check how we can find it. So we'll take a new slide, and we have the new unit of length is equal to 10 centimeter, and new unit of mass, that is equal to 10 gram, and we have the new unit of time, that is equal to 0.1 seconds. And you know that the equation for force is equal to mass into acceleration. Our mass is expressed in kilogram in SI system, and acceleration is meter per second square. Okay, or together we can express this kilogram meter per second square as in terms of Newton. So the unit of force is Newton. So using the equation q is equal to n1 u1 that is equal to n2 u2, we can write in SI system we have 1 Newton, or in other words 1 kilogram meter second raised to minus 2 is equal to, we don't know the value of force in new system of units, so we take it as n2 into new unit of mass is 10 gram, and the new unit of length is 10 centimeter, and we have the new unit of time that is equal to 0.1 second. Okay, so we have to find the value of this n2. Therefore n2 is equal to, we have to bring all these to this side and okay, we can write one let us keep it as like that, 1 kilogram divided by 10 gram multiplied by 1 meter divided by 10 centimeter multiplied by 1 second divided by 0.1 second the whole raised to minus 2. Okay, you know that 1 kilogram is equal to 1000 gram. Okay, and we have 10 gram, then we have 1 meter is equal to 100 centimeter, then we also have 110 centimeter and downwards, and second that remains the same. Let us keep it as, you know, the 1.1 second is 1 by 10. Okay, so 1 by 10 second. Okay, so cancelling gram and gram, and also we can cancel this 2 zeros with 0, and we have centimeter cancels, and this 0 can be cancelled with this 10, and we have second and second cancelled, and we get 1 into 10 into what remains here is also 10 into 10 into, sorry, we here are 100, so mistake. Here we have 100. Okay, we have 100. I'll write it. Sorry, my mistake. Okay, so we have 100 into 10 into 1 divided by 10, that is 10 raised to minus 2. Okay, so in other words we can write it as 1 into 1000 divided by 10 raised to minus 2. 10 raised to minus 2 is 1 divided by 10, the whole square. 10 square is 100. Cancelling this and this, we get 10. Okay, so what we get here is, what we get the value of n2, we get the value of n2 as, okay, we get value of n2 is equal to 10. Okay, so what will be the answer? 10. We get 10, right? So you may write the answer as 10 Newton. Is it correct? No, actually it's wrong. Here we have to check what it is asked. We are asked to find the unit of force in the new system that will be equivalent to. So what this means is, we have n2 is equal to 10. That what we get here is 1 Newton is equal to 10 into new unit of force. We have to find the equivalent of this in the SI system. That is, 1 new unit of force can be written as 1 by 10 Newton, or in other words it is equal to 0.1 Newton. So this will be the answer. So we have to always check what it is asked in the question very carefully. So that's all for this session. Here ends this unit of measurement section. Actually this is a small section and very less questions are asked from this question. I hope that you all have understood what have we discussed here. Do let me know your suggestions and your comments, and also do remember to press subscribe and press the bell icon. And I hope your support too for the completion of next videos. So please support me and keep on studying, and all the best for your preparations. Thank you.